morning. My name is Dhanavaran. I'm going to handle a topic about forward kinematics in 3 degree of freedom manipulator. The topics which are going to be covered in this session is kinematics, degree of freedom, link, joint, type of kinematics, our problem which is this, and the solution which is required for the problem. Kinematics. Kinematics is defined as kinematics is a branch of mechanics which deals with the study of bodies in motion irrespective of the forces acting on the body. For example, in this example, we neglect the forces which are acting on the body and just study the body's motion. Degree of freedom. Degree of freedom is defined in the kinematic chain as a total number of individual motion available in the kinematic chain. In this example, we have 3 degrees of freedom for each joint. This is a rotational joint, and this is a pivoting hinge joint, and this is a pivoting hinge joint. The rotational joint rotates along the axis with an angle of theta 1, and the hinge joint will revolve with the angle of theta 2, and the third joint, which is also a pivoting hinge joint, will rotate in the angle of theta 3, and this is the tooltip. Link is defined as a rigid body with at least 2 nodes for another link to get attached to it. When we link 2 links, it is the place at which 2 links joint is known as node, and the motion can be acquired between the two links. It is called as a joint. Then we have the types of kinematics. There are basically 2 types of kinematics, which are forward and reverse kinematics. In forward kinematics, forward kinematics works on the fact that when we know the length of the links, which are L1 and L2, and the angle between those links, we can determine the coordinates of the final point, which is the tooltip, which we are going to find here. And reverse kinematics works on the fact that in forward kinematics, with the help of links and angles, we are going to find the coordinate system. But in reverse kinematics, it is exactly the opposite of forward kinematics, in which we know the coordinate point of the system, and we have to find the theta, which is angle. In both the cases, we will know the L1 and L2, which are the length of the links. Our problem, it is about we are having 3 joints as told before. One is a rotational joint, and this is a rotational joint, which can, the practical thing will be like this is the base, and it is fixed. This will rotate like this, which is this joint. It can rotate fully, and this is theta 2, which is a hinge joint, which will only move along this direction up to a particular degree, and this will form the theta 3 degree, this angle over here. So in this problem, I am taking to explain the kinematics, forward kinematics of a 3 degree of freedom. The links L1 and L2 are taken as 155 millimeter, and D2, which is the base distance, is taken as 120 millimeter, and the angles theta 1 is taken as 60 degree, theta 2 is taken as 30 degree, theta 2, and theta 3, which is which is taken as 140 degree. This is nothing but the, okay, let's define the axes. Now if you are looking from the top view, we will only see this. If we look from the top view, we will only see this, right? This from the top view. We will see a straight line from the top view. We will only see the x and y axis in the top view. So our axis will be like y axis, x axis, and this is z axis. Okay. The tool, as said, the d2 is the base distance along vertical direction, one vertical direction, which is 120 millimeter. Okay. In the top view, we can only see the x and y axis, and in the front view, we can see the z and x axis only. Okay. So to solve the problem in a three-dimensional manner, it is so very tough. So we will take only the two-dimensional, and we will solve it, and we will add three-dimensional properties to the problem. Okay. So while starting from the front view, to solve this problem, we also need to decap the basics of trigonometry, which are basically right angle triangles. We just need to know the basics of trigonometry, which are sine opposite by hypotenuse, cos theta, which is nothing but adjacent by hypotenuse, and tan theta, which is opposite by adjacent. So looking at this, we already know the theta 2, which is 30 degrees, and we also know this is the link. It is nothing but the link L1, which is 155, and this is 30 degree, and with that we have to find, to figure out z, we have to find this vertical distance, and we have to subtract this vertical distance from this, right? So to find the z is nothing but distance d2, which is base, plus this height. Let us give a name, which is no. Let us find the value, and we will add it. Okay. I need a calculator. Okay. So we need this. So sine theta is equal to opposite by hypotenuse, which is nothing but sine 30 equals the required distance x divided by 155, that is sine 30 into 155, that is x. Sine 30 into 155 is 77.5. So this is 77.5 minus this distance, right? If you wanna find this, we know this angle is 140 degrees from here. This whole angle is 140 degrees. So we already know this angle is 30 degree, and this is 90 degree, and the third angle will be let's take it as y, and the sum of the angle is 180 degree in a triangle. So 30 plus 90 equals 180 minus 120, 60. Y is equal to 60 degrees. This angle is 60 degree. So this angle is 60 degree. So if this angle is 60 degree, 60, okay, 140 minus 60 is 80. So this angle is 80 degree. We need this. Okay. So we will go cos theta equal to adjacent by hypotenuse, which is nothing but cos 80 equals cos 80 into 155 equals adjacent. (26.91) adjacent. So we have to subtract 26.91. We found this and we are subtracting it from this. Okay, so 120 plus 77.5 minus 26.91, that is our Z. Okay, 120 plus 77.5 minus 26.91, we get the answer as 170.59. and we found Z, and we also need this distance, this whole distance, so that we can know the arm length. If we know the hypotenuse of the system, let us take it as arm length, okay, which is nothing but A. Okay, so if we know this distance, we can calculate this and this are basically the same distances. So if we put this in this, and we can calculate x and y, we can find the coordinate system. So we want to find this. This is nothing but adjacent, right? Adjacent for this degree. So we know theta 2 is already 30 degrees. Cos 30 equals adjacent by hypotenuse, which is cos 30 into 155. (134.2). So this is 134.2, which we can have it as A1, 134.2, which is A1, and we have to find this. Let us take it as A2. Okay. To find this, we know. We'll find this by sin 80 equals opposite by hypotenuse, that is sin 80 into 155, right? Sin 80 into 155, 152.6, which is nothing but A2, right? Nothing but A2. So if you want to add these two, if we can add these two, we'll know the. If we add these two, we'll know what is the answer. What is this distance? And by getting this distance, we can know the hypotenuse, and we already know this angle, which is 60 degree. So we can find the x and y, right? So 130. Wait. Okay. 134.2 plus 152.6 equals 286.8. a1 plus a2 equals a, okay, right, 286.8. So this is 286.8, right, this is 286.8. So you have to find x and y from this. So if this is the angle, we take y as opposite. So sine 60 into 286.8 equals y, right? Sine 60 into 286.8, which is the hypotenuse. We have the value as 248.37. Have the y, and cos 60 into 286.8 equals x. The x value of x will be cos 60 into 286.8, sorry, 143.4. So we found the coordinate system of each and every axis. To write this as coordinate points, we will write it as x comma y comma z, which is nothing but x 143.4 and y, which is 248.37, and z, which is nothing but 170.59. So we found the coordinate system of this. So let us recap what we have done here. We have a manipulator arm which has 3 degrees of freedom. One is rotation, and this is which is by a rotational joint, and this is by a pivoting hinge joint. This will rotate like this, and this is revolve like this, and this is also a revolute joint. So what we did is we first converted this into a two dimensions. So from the top view, we can only see the y and x axis, which we calculated. And from the front view, we can only see the z axis and x axis. We saw also from the front view, we calculated the z axis, z point, and also we calculated the hypotenuse of this arm length, which we also calculated the arm length, which is in the, we calculated the arm length and we put it in the top view of the system. And then from the top view, we found with the help of the degree and the arm length, we found the x and y, and we put it in a coordinate system point. That is it. Thank you.